All right, this is the grand finale of Chapter 12, Section 7. We're going to do a quick review to start. So the least common multiple, I always like to think of if each of these were a denominator and what I would make that denominator equal to so that I could add all of these fractions. So essentially, if I look at my numbers first, I have a 2 and a 6. That means I want a 6 in every denominator, so I would multiply this by 6, and I would multiply this by 3. And then if you look at your letters, you have an x here and an x squared here. And x squared is the biggest, so everything needs an x squared. The first one would need an x, the second one would need an x squared. So the least common multiple is the denominator here, which is the same in all of them, which is 6x squared. So if we do the same thing with the next problem, this first thing is factorable, p times p minus 4. And this is factorable, p plus 4 times p minus 4. If we want these two to look the same, p needs to be over here, and p minus 4 is the same, and p plus 4 needs to be over here. So this is the same as this, which is our least common multiple. All right, just a review of simplifying. In this first problem, there's no plus or minuses, so nothing is linked. Anything on top cancels with anything on the bottom. So I'm going to go ahead and put the whole numerator together. That's 10x cubed, and the whole denominator is 21y. Nothing cancels, so that is our answer. In the second one, this numerator factors into x plus 3, x minus 3. And I'm going to put that over 1. And I kind of put my line through as well as my divisor because I'm not going to look at x squared minus 9 anymore. Anytime there's a plus, things are linked. They can't just be individually canceled. So we have an x plus 3. And the numerator then is 4 times x minus 3. And the denominator would be 1. I don't need to put the denominator. I could put over 1. It's all the same. And the last one, we do need to factor. So this first thing factors into x minus 6, x plus 5, two numbers that multiply to give you 30, that add to give you negative 1. This is the difference of squares, x plus 1, x minus 1. This is that. And over here, let's take a 4 out. We have x squared minus 5x minus 6. And then this is factorable even more. Two numbers that multiply to give negative 6, that add to give negative 5 are negative 6 and 1. All right, we're going to start canceling. My x minus 6 can be gone. My x minus 1 can be gone. The x plus 1 can be gone. So the entire numerator, what's left is x plus 5. And in the denominator is 4. So this last section is all about solving. Now we have an equal sign. So when there's an equal sign, there's two ways to think about it. You can either make a common denominator and then only look at the numerator, or you can cross multiply and set everything to 0 and solve. So, probably the easiest way to do this first one is to cross multiply because there's nothing added or subtracted. So, n plus 4 times 1 would equal 3n. So in order to solve this, we would subtract n and then divide by 2. So n is 2. Just a quick little thing, you need to make sure your solution is not an exclusion. I know that n cannot equal 0 because of that, and I know that n cannot equal negative 4 because you can't have a 0 in the denominator. So my solution is not an exclusion, so that is the answer. All right, same exact thing. We have two fractions with an equal sign between. We're going to cross multiply. And the reason we're cross multiplying, it might make more sense if you think of it like this. I don't want this h on the bottom, so I'm going to multiply this side by h. I'm going to do the same thing over here to keep the balance, and the h then cancels. That's why and how cross multiplying came about. So you can think of this next step, 2 times h plus 1, as cross multiplying, or you can think of it as, well, I don't want this h plus 1 on the bottom, so I'm going to multiply it to the top, which means I have to do the same thing to this side to keep the balance. These cancel, and that's how this is gotten. Alright, 4h times 2h plus 2. This is a basic equation. We're going to put all the letters on one side, all the numbers on the other. Isolate the letter by dividing by that 2. What you do to one side, you have to do the other to keep the balance. So h is equal to 1. And then again, let's make sure 1 is not an exclusion. H cannot equal negative 1. It doesn't. H cannot equal 0. So we're good. Alright, in this third one here, we have 3 times x minus 7 equaling 21x. So 3x minus 21 equals 21x. So again, you're going to solve this by putting all of the x's on one side, all of the numbers on the other. So subtract 3x. So negative 21 is equal to 18x. Divide by 18. So x is equal to negative 21 over 18 can be reduced. We can take a 3 out of both of those. So 3 times 6 is 81. 3 times 7 is 21. So it's really negative 7 over 6. That would be pretty hard to just randomly figure out. You could plug that in and check and make sure it works. Again, 7 is an exclusion and 0 is an exclusion. So if an answer is one of those, it is not an answer. So now you can only do that cross multiplying when there's one fraction and then an equal sign and then another fraction. So we need to put these like fractions together as our first step. So this would be 3 over a plus 1 equaling 4 over a. Now we can do that cross multiplying business. And then distribute. And then all of the letters on one side. And you always need to solve for positive a. So a would be negative 4, since 4 is negative a, and I would write it with my letter on the left. Just remembering a cannot be negative 1 or 0. So in this next one, we need to get a common denominator. So probably the easiest way to get a common denominator is to bring this over. So I have 6 over j plus 2 equals 4 over 2j plus 10 over j. I'm bringing that over by adding. And to make the common denominator on this side, I'd have to multiply this by 2. So this is really 20 over 2j. So on the right here, I have 4 plus 20 over 2j. I can make that one fraction. And then since I have one fraction equaling another fraction, I can cross multiply. 4 plus 20 is 24, so if you want to just write 24, it's going to be easier. All right, 24 times j plus 2 equals 6 times 2j. Now, before you go multiplying through, this 24 and this 6 have a 6 that I can take out of them, so I can divide this by 6 and divide this by 6. So I could write this as 4j plus 2 equaling 2j. 1 times 2j. So 4j plus 8 equals 2j. So bring the 4j over. 8 equals negative 2j. And then when you divide by negative 2, j equals negative 4. Just making sure that's not an exclusion. And it's not. Basically the exclusions are negative 2 and 0 and 0. Now, if you plug negative 4 in, just to quickly check, that'd be 6 over negative 4 plus 2 is negative 2. So this whole thing would equal negative 3. And then 10 over negative 4 is negative 2.5. So we'd be actually adding 2.5 because minus a negative. And does that equal 4 over negative 8? Because 2 times negative 4 is negative 8. 4 over negative 8 is negative 1/2. And it does. So if you want to plug something in and check it really quickly, that's a good tactic. All right, over here, 1 is the same as 1 over 1. And if I want the common denominator over here, I can make this a t over a t. Multiply by t. So on the right, I have 1 plus t over t. And on the left, I have my 8 over t plus 3. So we are going to cross multiply. 8t equals t plus 3 times, I'm going to just write this as t plus 1, so when I FOIL it all out, double distribute, it makes more sense. Okay, since I have a squared term, I have to factor the whole thing out, put everything on one side and set it equal to 0 so I can solve. So t squared plus t plus 3t plus 3 equals 8t. So t squared, I'm going to bring the 8t over. So 4t minus 8t is negative 4t. And that's factorable. So t minus 1, t minus 3. So I have two possible solutions, 1 and 3. Now just making sure negative 3 is an exclusion and 0 is an exclusion. So these two solutions do both work. Cindy mows the lawn in 50 minutes, so it takes her 1 out of 50 to mow the lawn. And Sarah mows the lawn in 40 minutes. And I want to know how long it'll take them to do one lawn. So x over 50 plus x over 40, I need this to be a common denominator. I'm going to multiply this by 4 and this by 5 to get them up to 200. So this is x is like x over 1. So this whole thing is x over 200, 4x over 200, plus 5x over 200, 5x over 200, equaling 1. So 9x over 200 equals 1. So to solve that, we would cross multiply. So 9x equals 200. And then you would isolate the x through division. So 200 divided by 9 is 22.2 repeating minutes. And that makes sense. One can do it in 50 minutes, one can do it in 40 minutes. That does make good sense. Copy machine A can make 200 copies in 60 minutes. Copy machine B can make 200 copies in 10 minutes. How long will it take both machines working together to make 200 copies? The 200 copies is like one job. So I can write this as one job in 60 minutes and one job in 10 minutes, equaling one job, because it's 200 copies. That's just a job, one full job. So let's multiply this by 6 to get a common denominator. So x over 60 plus 6x over 60 equaling 1. That's 7x over 60 equaling 1. So 7x is equal to 60. Now, we get 8.5714 minutes. Now, this does make sense because if the 1 can do it in 10 minutes, if it has this helper here that takes an hour, this very slow helper, it's going to still take less than 10 minutes because it has a helper. So our number should have been less than 10 minutes. All right, hopefully chapter 12 you're feeling super proud of. And that is all for the day.